Welcome, DevOps. Okay, take some time.
It's a tough crowd. It's a tough crowd.
Yeah, okay. You also don't know us yet, so maybe first have to introduce ourselves. I'm together with Tim van Eijndhoven, presenting this talk. We're both coming from working at JPoint, small consultancy company at the Netherlands. We work for different big clients in the Netherlands. And we made this pet project. We didn't do it alone. So this is the JPoint team. So we worked together on this a bit. Some more than others. Some only had fun with us. Some really wrote some code. Some, like Venkat said, only architected it. So what we wanted to do is, we really like to go to conferences. So the JPoint crowd is also with a big part here. And we also like that the people that are organizing these conferences are taking pictures. We like to scroll to those pictures. We like to look at all those pictures, but we really don't like to search for those pictures where the speakers are on. So, for example, if I spoke at the conference, I want to have my pictures, and it takes always like clicky through more than 1,000 photos to see if I'm on a certain picture. So, as all good developers do, we automated this task. So we're using, you probably saw already in our abstract, that we use Quarkus, Grail. We use the AWS CDK to set up the infrastructure. And we use AWS Rekognition to do the photo detection. So when we started with this project, we had a couple of goals. So the goals were to automate everything, like we all want to do, of course. We want to learn something. And it should be some new things. Well, Grail is a bit new. Quarkus is a bit new. And we want to have fun. So how did it all started? With JPoint, we go for a tech weekend. So we go out to some big house where we sit together. We split up in groups. We do certain projects. This year, team was using the power of the cloud. So we did a couple of projects with cloud software and tools. And we code on that project, and the goal was to have an end product for all these things. Of course, we also used a bit power of fun, so to make the tech weekend also nice for us.
Everybody needs a break sometimes, right?
Yep. And the end result was actually some face recognition as a tool that we wrote that was also used by Stefan now in the DevOps talk, or the DevOps pages, where we actually, like he explained already in the keynote, he used the avatars of the speakers and he searched through the old Flickr images. And he used to put those Flickr images on the speaker pages.
Right, so that's how it all started. So our theme for our weekend was using power of a cloud. So you have nowadays these clouds with all these services, all interesting services that you could leverage for your own, for solving your own business problems. So in this case, we looked at the AWS Recognition Service, not only the AWS Recognition Service, but also to the services from Google, Google Vision, and on Azure. Now we got the best results from AWS, and it was the most comfortable for us to use, so we decided to stick there. And after we created a proof of concept during the weekend, we then took a hard look at it and said, well, can we make this into something maybe more like a product? So we decided to take the learnings that we had from the weekend and then design the system over. And we came up with a serverless solution, because serverless is still hip and happening, even though it's probably 2017, 2018-ish, but okay, we still thought it was quite cool. So we went full on into the AWS cloud infrastructure. And what we created was a system consisting of lambdas to execute our program code, of DynamoDB to store some data that we needed to persist. And in the middle are both queues to communicate between the lambdas and S3 and Rekognition in order to be able to analyze the images. So we have three main services. We have the photo search first. That's where you post your picture to, and then you get a list of images where your face is recognized. You get that returned. We have the creation of an event. So our vision is that events like DevOps, but maybe other conferences can use this type of tool. So they will have to manage their own events. So for example, Stefan could choose to make one large DevOps event with all DevOpses over the previous years, the pictures in it, or he could choose to do it per year, for example. And the third one is an endpoint that Stefan can trigger in order to import a photo album from Flickr. So we only support Flickr at this moment with their API. So those are the three APIs, so to say. Now, we chose this architecture mainly because it's cheap. It was also a learning experience for us, but the nice thing about these lambdas is they're not continuously running, so we're only paying for what we're using. The same goes for the Dynamo database that was sufficiently suited for our use case, and the AWS Rekognition Service. So we only pay for use. So whenever it isn't used, like at this moment, we have very few costs on this architecture. Now the main components, as I already mentioned, were Lambda, SQS. We chose to put the SQS queues in between the lambdas in order to decouple them. So we were not sure about, we weren't experienced with writing code with lambdas, so we weren't sure how big they should be, how many functions should they actually have. So this way we could decouple them and change our architecture whenever we wanted. It gave us flexibility. And with regards to DynamoDB, for us, the data that we store is really, really simple. We try to store as little data as possible, which we'll come back to later when we talk about privacy, for example. But this allowed us to use the DynamoDB for storage instead of, for example, the RDS service that AWS offers or their document store. Now, at the heart of the system is Amazon Rekognition. And this basically does all the heavy lifting when it comes to the image analysis. And this service that Amazon offers you is a service to do both image and video analysis. And it's based on, well, deep learning technology, as they say themselves. And they basically train the algorithm and keep training stuff and adding features. And this way, we did not have to delve into the complexity of trying to train an AI to do this for us. Also, the results that we got back from the service were that good that we simply didn't see the need to train a more specialized algorithm, for example. So the services that they offer are both stuff like detecting objects and images, well, the facial recognition that we use. They can spot safe or unsafe content. They can even find text in images, so you could use it for image to text. And well, we basically only use the facial recognition part of it. Now, the way we use this tool is to make a collection per event. So we envision this thing that we are building as a tool that can be used for multiple events. And what we do not want to do is that when you search for a picture for someone, that you're searching through all these events at the same time, right? So you only want the relevant pictures that you're on. So we build a collection in AWS Rekognition per event. Whenever we download a picture into our S3 bucket, we trigger the import into Rekognition. So you have to explicitly do an API call to Rekognition to tell it, well, here is an object in S3, an image object in S3. Now detect all the faces in this image for me. It will provide us with the results, so it will tell us where the faces are and some features and all the analysis result that it provided. And what we do is we store that result. So we store that result with its only purpose is debugging. So Rekognition is a black box for us. And when we want to know, it's, well, hey, we know that this person is on this picture. And we feed it a facial picture of the person, but the picture isn't found, for example. Why? And this way we can basically overlay the analysis that Rekognition did in order to see, for example, oh, well, it didn't detect the face in the first place. So that's the idea behind this debugging information. Now, mind you, that this has never been used to actually analyze any problems that we had with Rekognition, simply because it's that good that we even had a situation in which a few pictures from the Devox import failed on us, and we recognized that these pictures were all pictures of the audience, right? So not a picture of purely a speaker, but shot into the audience, lots of people. So at one point I thought, well, maybe the Rekognition algorithm simply breaks on having that many faces in an image. It turned out that was not the case. It detected all the faces, minus perhaps 2 people who were bent over their laptops, right? So there wasn't much of a face to see. It recognized all of them, but that meant that when we took that response and tried to store it via an SQS queue, the message got too large. Anyway, so the problems came in a whole different area than where we expected them. Now, what we do as well is we have a little trick. We do not want to store the pictures in our own AWS account. So we need to be able to, when Rekognition tells us this image contains the face, we need to be able to translate that back into the original URL of the image. So what we do is Rekognition has an external ID field, which can be used to relate the image that is analyzed in Rekognition to an image that you have. And we store the original URL in that field. Now, there are some constraints to that field with regards to the characters that can be put into it, so we hex encode that. And the last part is basically whenever we search for an image, we call the search faces by image function. It's one API call. We feed it the binary data of the picture where the face is on, and we will get the results back. So it's relatively easy to use. When we built the code, the lambdas, we started to look into, well, what technology should we use for building these lambdas? We are Java programmers. That's our main thing. You see a lot of lambdas written in, for example, JavaScript. We're not really comfortable doing that, so we wanted to stay within our own comfort zone and use Java here, not trying to learn a new language like Venkat just advocated. So then we went into, well, but how can we make these lambdas that are running Java code as cheap and fast as possible? So we looked into the new hot topics of, well, basically this year, Quarkus, and perhaps even a little bit last year, GraalVM, and decided, well, let's try this stack out to see if it will fit our needs. So first onto GraalVM. So who of you have heard of GraalVM? Who of you have actually used GraalVM? Okay, that's a few hands. So there are, I think, about half the room actually heard about GraalVM, and I think about 15% of the room actually used it. Well, GraalVM is a new virtual machine that's developed by Oracle, and in its nature, it's a virtual machine. So most of us have heard of it in regards to compiling native images. But first and foremost, it's a virtual machine, just like the virtual machine that we have now. They've done a lot of nifty things in this, so it's a really cool thing. And one of the things that they managed to do was to improve performance, and they really went into what type of workloads are are more relevant nowadays than they were back in the days when the old VM was designed. And so one of their features is being polyglot. So you can use different programming languages and all compile them and run them on GraalVM. And that means you can integrate them. So you might ask, what's the use? So we have at the place where I work daily, which is the Dutch National Police, we use it in a situation where we have Scala code that needs to integrate with R code. And using GraalVM, we can call R code straight from our Scala code. So that's a really nifty trick. In one of the deep dive sessions last Monday, Oleg Selayev and Thomas Ruttinger, they showed that when you do this, you are actually able to debug across all these different languages. So you have a process running that's running code written in JavaScript, in Ruby, in R. You can basically connect the debugger, set your breakpoints, and manipulate the data all across these languages that would normally have some sort of boundary, right? So an API calling. So that's a really cool feature. The feature that was most relevant to us was that it was able to compile these native images. So looking at Lambda, pricing is based on time. How much time does your Lambda take to run? So reducing that time to as little as possible seemed interesting to us. So we thought, well, let's try this native thing, because that would mean that the stuff would start faster, would take less time, would cost less. I'll get back to whether that's a good argument or not. And the other one is that it reduces memory footprint. And that's the other factor that decides how expensive a Lambda is how much memory should be allocated for it. So that, I mean, both aspects would be beneficial to us. Now, the last thing is that it seems to be, I don't know the details about this, but it's embeddable. And they even have cases where they can embed GraalVM into an Oracle database, which sounds really cool, but anyway. It's Oracle, right? So let me get back to this native stuff. So let's make a comparison between ahead-of-time compilation and just-in-time compilation, and look at why this is relevant to us. Because it's not the case that making a native image is better or faster in every case. If you look at 5 aspects, and I mean I stole this graph from Thomas, who was one of the GraalVM developers. And if you look at different aspects like peak throughput and reduced max latency, then you see that a JIT is still better. Because what a JIT does, it analyzes the usage patterns of your application. And it looks into what's actually used and what type of data is actually flowing through my application. And then it can optimize the code for handling that stuff. And therefore, it's able to optimize it more for the actual workloads running through the system, in comparison to ahead-of-time compilation, which can only do assumptions when compiling. It can only do assumptions on, well, the code is structured this way, so it will be used, probably used in certain ways, so we can put in these optimizations, but they do not necessarily hold up in every case. So you see that just-in-time is probably still better for those workloads, which are mostly workloads of systems running for a longer period of time. Now for us, the low memory footprint and the startup speed, as mentioned before, were the main arguments to choose this. And with regards to that startup speed, that's not really a good argument, to be honest. Because lambdas in AWS, when they are invoked often, they will remain hot. So you only incur the startup penalty once, and then they will be kept alive, and they will be kept running. So there's, I mean, the profit there is only a little, only the first time it starts. We have a case in which the lambdas are not continuously being called. So in our case, a lambda will start, runs, and then it will shut down after, I think it's 10 minutes that they say. Well, in that case, you might say, well, then startup speed is interesting because you have this benefit every time it's called. But there's a reason why it's constantly starting up. There are not that many calls to that Lambda. So basically the amount of times that the Lambda runs are so few that the costs you save with the faster startup are basically negligible. So it's not that strong an argument, I think. The memory footprint, however, is because if you can make your Lambda fit into a smaller sized Lambda executor, that will basically halve your costs. So that's an interesting factor. Now, GraalVM came with its challenges. So it was cool. We got it to run. We got it to run in its own runtime within the Lambdas. More on that later. But using this ahead of time compilation with GraalVM is not for the faint of heart, so to say, because you will get into a world with issues that you didn't have before. For example, one of the things that bit us hard multiple times is reflection. So I think most of you who have actually seen talks on GraalVM or read stuff about it will have heard about this issue. So GraalVM, when building the native image, can only analyze which code is called, right, by analyzing the actual code. So whenever reflection is used to instantiate stuff, it isn't aware of the classes that are used there. So you have to make it aware to do so. And that meant for us that we had to by hand configure which classes and which type of methods needed to be provided by Graal when building the native image in order to work. And this is all fine when you're looking at your own code, which is doing reflective stuff, but you have to keep in mind that you're using libraries, which are also using reflection internally. And analyzing that whole tree, well, that's a pain. So we ran into it more than once using the AWS libraries, which use Jackson serialization, deserialization for the API calls that they do. Now, Graal provides a tracing agent, which you can connect to a running process. So the process that's running is not the ahead of time compiled process, but is still just a just-in-time process. And it will, when you send different workloads through that process, it will monitor which things are loaded by the class loader, for example, which call paths are actually used, and it will create these files for you. We didn't leverage this enough, so it costs us a lot of effort to build this to build these files ourselves. Now, another thing that you might not have in mind when you're doing this is you create a native image, and then you do an HTTPS call, and stuff breaks. It just breaks. Why? Because there is no support for example, a trusted root certificate. So you will have to provide your own trusted root certificates. I mean, you might not be aware of this, but whenever you're running on your normal JVM nowadays, the certificate authorities are provided by the JVM to you. So in this case, you will need to take such a file, which is called CA certs, and then add it to the resource of your application. Then the next problem occurs. Some of this cryptography, which is a nasty word, is based around elliptic curve algorithms. You need a library to do that sort of stuff, which is also not provided. So you will have to get a libsun EC to add to your project. So, I mean, you get into this world of new things that you didn't have before. So keep that in mind when you're starting using stuff like Graal. Quarkus actually has a guide on this. So basically, we were able to follow that guide in order to know what we had to do to fix it. But you run into it the first time and you think, what the hell is happening here? Now the third one is development speed, and this is also part to our process, because what we did is we made code changes, then straight compile to native, deploy the native Lambda, run it, see there are issues, go back, change the code, compile it to native, and every time we compile it to native, you have to wait, because ahead of time compilation takes more time. And on my laptop, and this is a 5-year-old MacBook, to which I was, a couple of months ago, I was convinced, well, it's fine. I do not need a new one. It's okay. It's still running. It's all fine. Well, trust me. Now I started using Graal. I want a new laptop. So when you start doing this, please, please, please first make sure that your code is correct, just using the JIT process and not yet the natively compiled stuff, and then go to that world in order to solve the issues that you have there. So the second major part of the code that we use is based on Quarkus, and Quarkus is the hot new framework that's been promoted since, well, the start of this year, I think, mostly. And it's built by Red Hat, and it advertises with being a Kubernetes native, well, blah, 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 whole tagline. For us, it was an interesting choice to make, because it's a framework that is aimed at being used with, for example, GraalVM. So it's already built in such a way that it will behave nicely when built into a native image. Which, for example, with Spring, is still a more difficult subject. So what Quarkus does is it's built with container technology in mind. So they are helping you build these native images because they work better. They are able to provide you with build tools that build Docker images for you and whatnot. So that's really nice. It has both imperative and reactive patterns that you can use interchangeably in code, which is nice, but wasn't really applicable to our use case. It sparks developer joy. Oh, that's nice. We like to have more joy when coding, right? I mean, I do. And it does. In the demos that you see the Red Hat people do, you always see the hot reloading, right? So you write code, you run it, and then you change it, and boom, code is changed immediately without even noticing. You directly use the new code, which is a really cool feature. But in our case, when locally calling the lambdas, which are calling Amazon services, already a pain, it didn't have much help. And the other one is what advertises being the best of breed for using the best of breed libraries and standards. So it's based on already known technology. So that's nice. A good feature to have, I think. So for us, the two things that were important were, on the one hand, that it provided us with the tools to build our native images. So we did not have to dive into Graal and precisely know what we needed to do in order to build this native image. We just took the Quarkus tools that are provided in their Maven, with the Maven file, and basically just activate a profile native, and it will build and compile the image, the native image for us, based on the code that you have. So that's really nice to have. So that took a lot of complexity away from us. The other one is that Quarkus actually has a plugin which provides the Quarkus Amazon Lambda, or it has the Quarkus Amazon Lambda plugin, which provides the Lambda functionality. So when running a native image on AWS Lambda, you will have to provide your own runtime. Because when you're creating a Lambda, you can choose from a Java Lambda or a JavaScript Lambda or Python or whatnot. But in this case, we have the binary, run this. And in order to do that, you will have to have a layer which actually integrates with the call that's being made to the Lambda to start it up. So this way we can write, from our perspective, our code just being as a regular Java Lambda, but then Quarkus takes care of actually translating from the Lambda invocation into invoking our code as if it were a regular Lambda. Now Quarkus has its challenges of its own. So one is documentation, which is basically, I mean, we're used to using Spring and the vast amount of documentation that's there. If I have a problem, I'm pretty sure that there are a dozen people who had the same problem, actually already took the time to post a question and have even more people replying to them on how to solve it. So with Quarkus being the new kid on the block, that amount of information is not yet available. So that means that whenever you have a problem, trying to find the right answer for your problem or trying to find the documentation that will help you solve the problem is just a bit harder. And if Quarkus is here to stay, this will be something that will solve itself over time. The other one is the Lambda compatibility. We ran into an issue which basically showed us that the Lambda code that Quarkus offers is different from the Quarkus code, from the Lambda code that Amazon actually uses for its Java Lambdas. And the difference was that the case sensitivity when it came to Jackson serialization and deserialization. So we ran into the issue that we got an SQS event, which is just within the AWS APIs is a class that you can use, and I mean that class is offered by the AWS SDK, so that should pretty much be to spec on the actual JSON coming in, but it still would break when it tried to convert the JSON into the object because of casing in the properties. So Amazon basically offers a case-insensitive Jackson to Lambda, whereas Quarkus did not, and it broke, so we had to work around it. In a later release, that was solved, but you still have to keep in mind that you're working with technology that's not yet as finely integrated as just regular Java Lambdas. The last technology that I want to highlight is the AWS Cloud Development Kit. So we had to build infrastructure in the cloud, right? A serverless application, and we needed to manage it, and that is actually something that takes effort. So I'm working with cloud environments now for the last 5 years, and I'm used to writing, for example, CloudFormation in the case of AWS. And we started out with writing CloudFormation in JSON, and we all hated the large JSON files, which was nasty. And then they offered us YAML. And we went, yay, YAML, that's way more readable. Yeah, that is until you get to a certain amount of lines of code, and then you have to worry about indentation and not seeing it all, and then YAML was a bitch as well. And then on the other hand, you have, for example, HashiCorp's Terraform, which offers its own language, but it's still just a static specification. I mean, the whole promise of infrastructure as code, to me as a programmer, was like, oh wow, now I can program my infrastructure. But that's not the case. With the AWS Cloud Development Kit, you can. So they advertise it with the easier cloud onboarding, because you can use these existing skills, right, to build it, and you can use the existing tools. So, for example, the CDK is available in Java, so I can write Java code to program my infrastructure. It's also available in other languages. So whenever you develop in another language, you can use CDK when it's available, of course, in that language that's natural to you. Being just Java code, you can make your own abstractions, right? So now I can choose what is relevant to me in abstraction. Do I want to speak about having a function, or do I want to create something like a service, which will underneath create a function and, for example, a queue or whatnot? I can decide on my own. And whenever I make this, I can offer it as a library or whatever, and another programmer can use it. And you can use your IDE with it. So also code completion, for example. That's just a nice thing to have when you're defining infrastructure. So the main benefits for us were infrastructure as proper code, right? So we just write code. We create objects representing our functions, our queues, our databases. And then we run a command line or a CLI command in order to convert that into CloudFormation and apply that to the cloud infrastructure. And that command line interface, the CLI, will also provide us with a really nice diff viewer. So I can just run a CLI diff, and it will show me what differences my change to my code will make to the infrastructure, which just make the whole turnaround time in the workflow that much easier. But then again, this technology had its challenges as well. So one of those things is missing features. We're using technology here which is only recently been developed, so it's not yet as mature as the, well, for example, CloudFormation that you can use. So it was missing some features. So in order to be able to do that stuff, we still had to revert to using CloudFormation for that part, and then use the CDK for the rest. Now, the good news is that development on the CDK is really, really rapid. So that means that the problems that we had were solved weeks later in a new release, and we didn't have to revert to CloudFormation again. Now, the downside of that really fast development process is that it will break stuff. So be prepared to fix your code whenever you upgrade to a new version, because they will break compatibility. In all honesty, it never costs us that much time. But when you have a really large infrastructure, that might be more painful. So we've been talking about the technology. Let's show you what it can do. So I want to start out with the tweet from Devox, from Stefan, when he integrated this into the website, like, yay, we have this facial recognition stuff, which is really cool. And then we got a discussion on GDPR, which we'll come back to later. But it also went into the power of the engine, right? It found people in pictures that couldn't even find themselves in their picture. So in this case, it's Mario Fusco who cannot find himself in this large crowd. So let's try to solve it for him. So I have a simple UI here, which is basically only for our development purposes. Let's feed it a picture of Mario, and it will get back to us with the pictures where Mario is on, and this is the one that was used in the tweet. So let's highlight, and this is where it thinks he is sitting. Let me zoom into this. I mean, it could be. I don't know Mario that well, but okay, I could make the same decision. But we notice some other things as well. So when you look at the power of this thing, then, for example, take a picture of my former colleague Bertjan, who was at Devox UK, and I was looking at the pictures which had a lower confidence score, right, to see if there were false positives or if I could say something about it. And it found Bertjan in this picture, and which I thought that's amazing. I mean, how can it find? This is Bertjan. How can it find Bertjan by looking at the back of its head? That's impossible, right? And then I looked at the highlight, and it's in the reflection. So this is really cool, because you zoom in, then it's actually quite impressive, because it's only half a face. I mean, the lighting is, I mean, the lighting here is even worse. It's even darker than it is on the screen. But I mean, it's amazing that the algorithm can actually find him in this picture. The same happens when you, for example, find Stefan. And I actually, after the keynote, I went up to him to ask him about this picture that I'm about to show you, if it was really him, because I wasn't even sure. So there's nobody here. Was a person with his back to the camera, but there's the poster, and there's Stefan, being the godfather. Oh, anyway, never mind. So those are cool things to see. So actually, the algorithm is really, really powerful, and it can find people in places where you wouldn't even look at yourself. I also had this one from my colleague Roy, who presented as well, and then I thought, hey, there's Mr. Qubit, his co-presenter, right? The Skippy ball. Let's try this. So I made a cutout, and I tried searching for Mr. Qubit. Now, unfortunately, this doesn't work. Rekognition doesn't see a face in here. So Amazon really needs to work on finding Skippy balls in pictures, right? So that's basically what it does. And I mean, it's that easy to use that I would even say, well, when you have your own personal album, just try to work it with AWS Rekognition in order to find the faces of the people that you want to find in your own personal albums. It's not that much work to do. let me get back to the presentation. So I will hand over to Roy to talk about the flip side of our technology.
Yes, GDPR. So we didn't put it in our abstract because then the room was not large enough. Everybody is here, of course, for GDPR.
Of course.
Thought so.
It's a sexy topic.
But I think I do think it's an important topic because, well, for those of you who don't know, GDPR stands for General Data Protection Legislation. So it will apply to all European citizens. So it's there to protect your privacy and your data.
I feel so much safer now.
Right? Yeah. Is there just to give more transparency, like how your data is being used? So if you look at face recognition, how does that apply, the GDPR regulation apply to face recognition? So in face recognition, actually, we have 3 types of data that's being used, privacy data. So one of them is processing the image where you're on, right? Just the bare image. Then it's the physical characteristics. It's like, do you have a mustache, eye color, etc. And behavioral characteristics, like you're smiling, etc. So these are the 3 things that actually are that you have to give consent on when your images are used in the face recognition. By the way, physical and behavioral are biometric data, so they're combined in biometric data. So what do you need to do when you want to be GDPR compliant? So there are 2 things at least that you have to do. That's let the user give consent of using your data. So in this case, your image and your biometrical information. Be transparent about how you're going to use it. And give an option to withdraw. So if you want to opt out, or you want to have the right to be forgotten, then it should be an option that you should be removed from everything. So like Tim said, when DevVox actually promoted this tweet about, hey, yay, we're using this face recognition, actually immediately somebody, I think it was 30 minutes later, said like, hey, that's interesting. But did they really accept, or did they give actually consent? And are you making clear how you're going to use their data? So DevVox got that covered, of course, because otherwise we didn't do that. So in the speakers, when you submit a talk in the speaker portal, you will actually accept the terms that your data is being used. So this is all covered. And the other side, the flip side of this technology can also be used, like Roy Verijn is mentioning here, to actually opt people out. So let's say they want to be forgotten in the Flickr albums. Then actually this technology can be used to search all the pictures that a person is on and remove it. Right? So we should always think about GDPR, and we should, well, be compliant with it. So what did we do to make it GDPR compliant? So we assume that the consent is always given by the owner of the project. So in this case, DevVox uploaded used the Flickr album to do the face recognition. And then we actually assume that the project creator is aware of this consent and made sure that everybody that's on the pictures gave the consent. We only search within the project. So we don't search through lots of projects. We only search to the project that somebody created. We don't do names correlation, because that's a different consent that you have to give, that your name is bound to an image. We don't do that. It's just abstract numbers. We don't recognize any names in it. And we don't store the images ourselves. So, because you have to be transparent, right? So otherwise, DevVox should have said that we are storing images for their use. Then about ethics. I think there's a lot to do about ethics this time, about face recognition. Amazon even also raised this topic. So if we look at image recognition, it's like you just saw it in the demo, it's very powerful. So Amazon also, some law enforcements are using this, for example, for catching criminals. So they use material, the fast-growing number of surveillance cameras. They use it to track criminals. They also use it, for example, to find missing persons. In medical use, they use it, for example, to make pictures of faces to see do they have pain, or some pictures of your scars, etc. What happened to you? Also, there's Alipay, right, where you can pay with your face. Also uses face recognition, I hope. And there's advertising. So when you walk in a certain store, you get only the advertisements that you actually want, or actually maybe it even can show you the path to the products that you want.
Without advertisements.
Without advertisement. Okay. But it has a downside. So image recognition is also dangerous. And it's clear with tracking the criminals or catching the criminals, what happens if there's a false positive, right? They will lift you from your bed and you're not the guy that you actually are.
That's actually the thing that Amazon raised, right? So
Correct.
you need to always have a human auditor of the results.
Yeah, so indeed, like Tim is mentioning, Amazon has 6 rules. They're also working with the Senate in the US to get some legislation on these rules. And one of the rules is that they say, like, if you do this with law enforcement and you make decisions that will affect the privacy of a person, then at least it should be 99% clear, and there should be a person that actually does the check if it's really true. With privacy, some people don't want to be found, right? But the health concerns, you might provoke unnecessary concerns, wrong checks, etc. Identity fraud is a difficult one, like, because if you have Alipay and your identity is being stolen, then you cannot easily get a new face. It's possible.
It's
but
expensive, right?
It's kind of expensive. So which means that actually your face will always be, you cannot use your face anymore because it's been compromised. In case of a credit card, etc., or identity with a document, they can just invalidate the document, which is a bit easier than identifying your getting a new face. And with advertisements, sometimes you get mails in your spam box that you might not want to be in the open when you walk in a store. So, right, you don't want to, you have your secrets, and you want to keep them. Which actually makes me think, and also I think the keynote of this morning, I was once in a National Karate Federation as a board member, and I had really difficult decisions to make, actually, that actually also affected persons. And then I went to my teacher in karate, we call that a sensei, and I went to him like, okay, you've been in the board before, how are you making these decisions? And he said, well, every morning when you brush your teeth, watch in the mirror and tell yourself that you're actually doing the right thing. And I think that's what same with the image recognition. If you're using image recognition at a certain project, think about it, and think about it if you are really doing the correct thing. And it's the same with this keynote this morning, that we're saying, like, okay, we need to be inclusive, not exclusive. Also think about it and watch in the mirror and think about yourself. Am I doing the proper way of working, and am I doing the things that I also want to be treated as? Like, we have 1 minute left for questions.
Slide. So here's a slide that we will leave in the background. These are other talks on GraalVM and Quarkus at DevOps. So there are also events on Monday and Tuesday, which already are behind us, but they are recorded. So take a look at the recordings, especially the top one is recommended. Any questions? Gentleman there. That's a good question. The question is if we actually checked, we mentioned the memory footprint, and that cost us effort to reduce it. Did we actually check how much, by how much? No, we didn't. Basically because our lambdas were able to run in the smallest runtime available. So then it was fine for us. When you look at, for example, the top one, the deep dive, they will go further into this matter, and you will see that it's it's quite a lot. One question?
Did you consider other libraries or frameworks like Micronaut and Dagger?
Did we consider other frameworks like Micronaut? Yeah, they crossed our mind, but we kind of went with what was the most hip and happening thing at the moment. Yeah, right, exactly. So, thank you. I think time is up. So, thank you very much for being here. Enjoy DevOps.